Hi everyone, this is Julia. I'm going to be walking through Discussion 6 Abstract Data Types and Dictionaries. And this video will be put into two parts. The first part I'm going to be going over dictionaries, and the second part I'm going to go over abstract data types. So we can get started with dictionaries. Okay, so we have here dictionaries are data structures that map keys to values. So dictionaries in Python are unordered, unlike real-world dictionaries. And in other words, that means key-value pairs are not arranged in the dictionary in any particular order. So if we see this example using Pokemon, we have here Pikachu mapped to 25, Dragonair mapped to 148, and Mew mapped to 151. So Pokemon of Pikachu should give you the value 25, because this syntax means to grab the key, to give in the key, and grab the value associated with it. And similarly, if we say Pokemon of bracket Jolteon equals 135, then what this means is going to add a new mapping from Jolteon to 135 into the dictionary, and now we have our changed dictionary. So if we call the dictionary after making this change, it should reflect the change that we've added Jolteon mapped to 135. Okay, and similarly, we can also add Ditto mapped to 25. And now, if we call Pokemon, then we'll have Jolteon 135, Pikachu 25, Dragonair 148, and Ditto 25, and Mew of 151. Alright, so that's it for this small example. And going into more of the conceptual side of things, when we have a dictionary, we always need to make sure that the keys of this dictionary are immutable. And what this means is that it must be a value of the immutable class. So if you look up here with this diagram, basically any immutable data consists of integers, floats, booleans, strings, tuples, and you'll see here include dictionary keys, because dictionary keys must be in this category of immutable data. Conversely, mutable data consists of lists and dictionaries. So a dictionary as a whole can be mutable, and that's evident in your ability to add a pairing or delete a pairing or change a pairing, but the keys themselves inside the dictionaries must be immutable. And so that's what the point here is, that the keys of a dictionary should be immutable, and this includes numbers, strings, and tuples, but it also includes like floats and booleans, and so on and so forth. So, the keys are immutable, but the dictionaries themselves are mutable, so we can add, remove, and change entries after creation. And that's what we did over here. So we created a new dictionary, but then we can also add a pairing. Alright. So if we have a dictionary, we also must make sure that there is only one value per key, because if we try to assign a new value to the same key, it just will overwrite that previous value. So you want to be careful, because if you're expecting that it's going to make a new mapping, it's actually not going to. It's going to rewrite the value for that key. So the original value is gone, and now the new value is there. Alright, just to highlight this, one value per key, and those keys must be immutable. And to access the value of dictionary at key, we use this syntax. So it's really similar to lists, except that with a list you usually use like an index, like 0, 1, 2, 3, 4. And if your key is in a dictionary also called 0, 1, 2, 3, 4, this would be the exact same syntax. But usually a key in a dictionary can be something like a string to represent maybe like a name, pairing, or you'll see in Lab 6, when you make a politician, it has like a name, a party, and I think maybe an age. But basically, if you're going to use like 0, 1, 2, 3, basically integer numbers, you might as well, or these integer numbers as keys for a dictionary, you might as well use a list instead, because the list itself has indices already built into it. So it has this natural ordering that comes with a list. Whereas dictionaries are really meant for things like mapping some kind of name to a person, or like saying that like a list of students is this, like having a dictionary of students mapped to some list, whereas the list itself has like elements that are really associated with that certain index, because it's the first element or the last one or the middle element, and so on and so forth. Okay, so element selection and reassignment work similarly to sequences, except the square brackets contain the key, not an index. So that's just going on about the lack of indices here, where we have keys and not really an ordering to a dictionary. So to add a value corresponding to a key, or to replace the current value of a key, we use this syntax, which we saw earlier. And remember that this is to make a new mapping, and it also changes the mapping. And moving on to the next syntax, we have how to iterate over a dictionary's keys. So by default in Python, when you iterate over a dictionary, it will actually give you its keys. So if you say for key in dictionary, like so, or you also say for key in dictionary.keys to make it very explicit, this will actually iterate over the keys of that dictionary. And the reason why you would say something dictionary.keys is because this is actually the function that explicitly gives you the list of keys. Oops, can't write. List of keys. But if you ever like look into the details of this function, it actually doesn't give you a Python list of keys. It will give you something called like a dictionary key object or something like that. So if you want to turn it into a real Python list, you can call list on it. So you can say list of dictionary keys, and this will give you the Python list. So it's kind of similar to map, if you ever notice that map doesn't actually give you a list, and you would have to call list on the value that map gives you, or the output that map gives you, to make it a Python list. Okay, and if you want to instead iterate over a dictionary's values, you can also call the sister function to dictionary.keys, which is dictionary.values. So if you say for val in dictionary.values, it will iterate over the values in the dictionary. And now if you want to iterate over both the keys and the values at the same time, you can say for key, comma value in dictionary.items. And what this will do is it will look at every single pairing in the dictionary and temporarily assign the name, key, and value to both the key and value in that pairing. So you can do something like print key and value, and this will print out like all of the pairings. So it will say Pikachu 25, and I think like what did we have up here? I think Ditto 25, right? And then the rest of them. But this is also really useful in case you want to do something like maybe swap the key and the value, or like look at both the pairing, both the keys and values at the same time in order to do some kind of check. So this comes in handy a lot of times. Now if you want to remove an entry in a dictionary, you have this kind of funny looking syntax, which is to use the del keyword to delete that key and its value from the dictionary. So what you can do is just use a syntax to delete the entire mapping from the dictionary. So it just takes out the whole pairing. It's kind of misleading because you are deleting the key, it looks like you're deleting the key, but it's actually going to take out the whole mapping. So for example, you can say del of Pokemon Pikachu. So what this will do is take out that entire pair of Pikachu and 25. Alright, so for our last bit of syntax, we have dictionary.pop key. So the real difference between this one and the previous one we have up here is that, that dictionary.pop key will give you the value that you removed. So if we have dictionary.pop, or sorry, Pokemon.pop Pikachu, what this will give us is 25. So it's going to delete that pairing from the dictionary, but also give you back the value, because sometimes you don't actually know the value until like you delete it. So maybe you just wanted to delete the key, but you didn't really care for the value until you actually grab it while you're deleting it. So this one will give you the value, and this one over here will just delete it. Okay. And now moving on to the first question of this part of the discussion. We have an example using some dictionary syntax. So we have again our familiar Pokemon dictionary. And the first question we want to discuss is whether Mewtwo is in Pokemon. So this syntax means that it's going to check whether Mewtwo is a key in the dictionary. And you can see here that it's not. So it's going to return false. But if it were to say, like, if Mew is in Pokemon, then it would return true, because we see that Mew is here, but Mewtwo is not. And then length of Pokemon is going to count up all the mappings and then return that. So we have 1, 2, 3, 4, 5 mappings, so this should be 5. And now if we do Pokemon of Ditto equals Pokemon of Jolteon, what this is going to do is take the value of Jolteon and make that the value of Ditto. So we have 135 as the value of Jolteon. So Ditto is no longer 25, it's going to be 135. Now we have Pokemon of Diglett, Diglett, Diglett as a tuple equals 51. So that pairing is going to be added. And then I can just add it over here. Oops. Diglett, Diglett, and Diglett. 51. Okay. And our next change is going to set 25 to Pikachu. So we can also add that to our dictionary. 25 Pikachu. Alright. And now when we call Pokemon, it's going to give back this dictionary that we have up here. So I can rewrite it again just really quickly. So Jolteon 135, Pikachu 25, Dragonair 148, Ditto 135, Mew 151, and then let me just copy this. Oops. Diglett, Diglett. This thing came along. And Pikachu. And that is our edited dictionary.